All right, so today we're going to be talking about volume of prisms. Before we get into the volume, we need to recap what we've learned so far. Anybody remember what lesson 1 covered? Alex K? Say that again. Let me unpin. There we go. So lesson 1 dealt with the circumference of a circle. What is the circumference? Again, who can explain what the circumference of a circle is? That should have been done a while ago. What is the circumference of a circle? Olivia? Basically the perimeter of a circle. Remember, circle has a bent line, so it's not like we can just count sides like we do with a normal quadrilateral or a triangle or something. So if I were to get a piece of yarn and straighten it out and then wrap it around, say like my pencil cup, this would be the perimeter of the circle, which is the circumference. Who knows the formula for the circumference of a circle again? Everybody should know this, ladies and gentlemen. Wow. Pi times diameter. That's circumference. Then lesson 2, we dealt with area of different shapes. We dealt with quadrilaterals, which covered parallelograms, squares, and rectangles. We also dealt with triangles, and we dealt with trapezoids. I'm going to move that trapezoid over a little bit so give us more space. And remember, trapezoids come in different shapes and sizes. It could be something like this, which is going to autocorrect to a triangle. And we're going to go ahead and go with the area. What's the formula for the area of a circle, ladies and gentlemen? Pi times radius squared. And if it makes you remember, just put parentheses around that because the squared thing needs to happen first. You need to square the radius first and then multiply by pi. Remember, if you multiply pi then by the radius and then square it, your answer is way off. So square the radius first, then multiply by pi. What about the formula for the area of quadrilaterals? Remember, all three of these have the same formula. What is it, ladies and gentlemen? Area equals base times height. This is very important that you remember this because this is going to come into our lesson today. What about triangles? Area equals base times height divided by 2. Another way of saying it is area equals 1/2 times base times height. Either one of these is fine. Same thing. And then with a trapezoid, what's the formula for the area of a trapezoid? Parentheses, base 1 plus base 2. Remember, trapezoid has the most confusing one, base 1 being the top flat part, base 2 being the bottom flat part. So, very important that you remember that. Another way of saying it would be height times base 1 plus base 2 divided by 2. That's fine as well. So, you guys need to have these memorized because when you get to your test, they are coming back. Today, we are going to leave area, and we're going to go into volume. Before we do that, what makes area area? Let's be more specific. What does area always end in? The measurement what, ladies and gentlemen?
Squared.
Why? Who can raise their hand and tell me why it ends up being squared? Let's hear some different voices. Ooh, I guess I'm picking volunteers then, yes? And as soon as I say that, people stop making eye contact. Pixar, why do you think it's squared? Well, why is area squared? Circumference. Is circumference squared, ladies and gentlemen? Nia, why is circumference not squared? What did I say earlier about it being it's like a straight line? I wrap it around the cup, right? When you measure how tall something is, you don't say that there's something 5 foot something squared, right? So circumference is a line. It's a bent line, but it's a line. Area is not a line. Area is space, right? Area. My desk. What can fit on my desk? The fridge. That's an area. What can fit on that wall? What do we notice about area specifically? It's what? Nia? flat surface. Pixar, what else? Think more critically. Why 2? Look at the number 2. Why 2? It's 2 dimensions. Notice the 2 dimensions that are being covered here are always what, ladies and gentlemen? What 2 measurements are common with all of them? Base and height. And there's 2 bases on trapezoid, but base and height are in each one, except for circle, because circle's different, because circle doesn't have flat lines, so we ignore circle. Circle's the outlier, the different one. But with all these other shapes, base and height are there. It's 2 dimensions. We multiply base and height, which makes it a 2-dimensional figure. When we get to volume, however, bless you, volume deals with how many dimensions, ladies and gentlemen? 3 dimensions. So, we're going to introduce a rectangular prism here. This is a rectangular prism. Rectangular prism, here's an example of a rectangular prism. Volume is the amount that fits inside of a 3-dimensional figure. That should be in your notes. Volume is the amount that can fit inside of a 3-dimensional figure.
Can you repeat it again?
Volume is the amount that fits inside of a 3-dimensional figure. And remember, if I'm going too fast, what can you guys do? Watch the video later. I'm not going to stamp the notes today, so you guys can do that at home, or even today, get headphones and rewatch it, because it should be uploaded here in about 5 minutes after I'm done. So again, volume is 3 dimensions. It's not base and height. However, base does come back into it, and I'll explain how base comes in. But the 3 lengths that you're dealing with now, the 3 measurements, are length, how long the shape is, width, how wide the shape is, and then the last one, ladies and gentlemen, would be what? Height, how tall the shape is. So height makes its return. Before it was base and height, right? I'm going to give you a little hint. Base is here. Base is here. Base, however, is a little different. So think of like a 2-dimensional shape. Like a square, right? The base was the line on the bottom, right? That was the base. There is not a straight line on the bottom of 3-dimensional shapes because it's 3 dimensions, right? There's not just one flat thing. The base would be what? Look at this. What would be the base on this?
The bottom.
The whole bottom, and the bottom's not a line. It's a what?
Flat surface.
It's a flat surface. It's a rectangle. It's a whole face of the thing. So when you do, okay, side note, you may want to put this in your notes. When you talk about like a side of a 3-dimensional shape, it's called a face. So like when you roll a dice, the dice has how many faces, ladies and gentlemen? 6 faces, six sides. So the base of a 3-dimensional shape is not like a 2-dimensional shape where it's just a straight line. It's an actual face. It's a shape. It's an area. It's a 2-dimensional figure. So for a 3-dimensional figure, the base is a 2-dimensional figure. For a 2-dimensional figure, the base is literally just a line, right? So this is how base gets split up into 2 measurements now. Length and width together actually make the base. So this definitely needs to be in your notes. When they ask you, what is the base of this 3-dimensional shape? It's literally length times width. The base is made up of length times width. And I'm going to dissect this shape a little bit here and make it a little bit more see-through so you guys can see what I'm talking about. So when I multiply length and width, like you guys said, the base is literally the bottom part of the shape, right? So I'm highlighting the base right now. This is the base of that shape. Right there. It's a rectangle, isn't it? Again, when we have just a square or a rectangle, the base was literally just the bottom line because it wasn't 3-dimensional. And then this was the height. I can't do that with a 3-dimensional shape. So now the base is literally everything that you see in pink down there. It's a whole face of the surface. It's basically one of the sides of the 3-dimensional shape. One of the faces of the 3-dimensional shape. It's the bottom face. So when they ask you what the base is length times width. Okay? If they ever ask, what's the base? What do we think the base is going to be measured in at the end of it? Squared or cubed? Why? Let's rewind. The base is not three-dimensional. The base is a flat surface, remember? The base is a face of the shape, right? So what do we think? Squared. You guys know how to determine if it's cubed or squared? How many things did you multiply? You only multiplied 2. Therefore, it should be something squared. When you get to the volume now, and here's your formula for the volume of a rectangular prism. Volume equals length times width times height, or in other terms they say base times height. This is where it gets confusing because now you have to realize base is 2 different things. It's length and width. So I like using this version. This version's a lot simpler, especially if you don't have to identify the base. It's literally length times width times height. And since you're multiplying 3 different values, your answer is going to end in?
Squared.
Not squared. Cubed, because it's 3 dimensions. So, let me give you guys an example.
We can't keep that on.
Nope, because I'm about to switch it. So again, the base is length times width. And then the volume, so again, volume equals length times width times height. The base is length times width. So you need to understand the differences between the two. Height's pretty easy. It's literally how what? How tall it is. Length and width are interchangeable, but length is going to usually be the longer of the two sides, and then width is going to be how wide it is. So for this example, let's give us some numbers. Let's say the height, let's start with the height. Let's say that this box is, I don't know, we'll say 8 centimeters high, 8 centimeters tall. The length, way longer than 8. Let's say the length is 12 centimeters. And let's say that this is 5 centimeters wide. One person at your group, please grab a calculator calmly and responsibly. Just Jaden, you realize that the mic just picked that up, right? Don't do that. So with your group, all you have to do to find the volume is plug in those 3 numbers, multiply them by each other. Now, because of the rule of commutative property, does it matter which order you multiply? No, it doesn't. But let's backtrack. If I ask you what the base of this shape is, what are you multiplying?
Length times width.
Okay, so that case, it does matter which ones you multiply. So, 2 parts of the question. I want you to identify the base of this rectangle, and I want you to identify the volume of this rectangular prism. Go, with your group. Communicate. I'm going to pause the video. All right, ladies and gentlemen, you guys have had plenty of time for the base. What is the one group? Raise their hand. What is the base of this rectangular prism? Olivia.
60 centimeters squared.
Okay, 60 centimeters squared. Remember, it's length times width. So let's get a calculator and find out. So that was 5 times 12, or 12 times 5. So the base of this is 60. Okay? Now, the volume is length times width times height, or base times height. We found the base already because we did length times width, right? So now we can just take that 60 and multiply it by what, ladies and gentlemen? You just multiply it by 8. And the volume would be 480, help me finish it, centimeters cubed. Just remember, we did the volume and we multiplied 3 different measurements. And there we go. Pretty straightforward, right? Any questions on volume of a rectangular prism so far? Okay, this is where the textbook gets really complicated, and I need you guys to really pay attention, because if you try to learn from the book, you are going to get so lost. Yes?
Can you have a 3-dimensional circle?
That's called a... Yeah, we don't deal with that. But yeah. It's called a sphere. Okay, so now we're going to deal with triangular prisms. So before we begin with any formulas or anything like that, I need you to see what triangular prisms look like. Real world examples of triangular prisms, that looks like a what, ladies and gentlemen?
10.
So that's a tent. And Jaden, this would be a
House.
What does that look like? It's a ramp. So these are examples of real world triangular prisms. In my classroom, I don't have any, but you guys do. Alex W. specifically does right in front of him. He's got his binder. There's an example of a triangular prism. Triangular prisms are going to be made up of 2 triangles and 3 quadrilaterals. So again, a triangular prism is made up of 2 triangles and 3 quadrilaterals. When I break down the tent here, I'm going to break down the tent. If my pen will work. There we go. You'll notice the tent is made up of those 2 triangles right here. 1 and 2, the entrance and the exit, and the 3 quadrilaterals. The bottom part is 1 rectangle. And then the 2 sides are also rectangles. 1 right there, and the other one being right here. So, 2 sides, bottom, and the 2 triangles. Same thing with the ramp. I'm going to go ahead and undo this. With the ramp, if I were to break this down, we have the 2 triangles again. And then we have this back part here, which is a quadrilateral. This part here, which is a quadrilateral. And then finally we have our front part here, the little ramp part, which is also a quadrilateral. So 3 quadrilaterals and 2 triangles. The book makes it a lot more complicated than it needs to be, and online you'll see that the formula for an area of a triangular prism is base times height. Here's what the book wants you to do. The book wants you to basically flip the shape to where it is on top of a triangle. The triangle is now the base. It wants you to find the area of that triangle and then multiply it by the new height, or how tall it is. I think that's confusing as heck. Nia's already like, the heck did you just say? And I don't like that. So we're going to pull back, and there's another formula that's easier. The volume for the area of a triangle is very much related to what the area of a triangle is. Ladies and gentlemen, what's the formula for the area of a triangle again? Let's do the more common one. That's base times height divided by 2. So, with that being said, and now we're going to 3 dimensions, and we know that base is no longer base, what do we think the formula for the volume of a triangular pyramid would be?
Base.
Oh, he raised his hand. There you go. So this is this is an easier way of doing it. Length times width times height, and then you divide it by 2. This is how you find the volume of a triangular prism. You will still have all of these measurements. Height being indicated by a 90-degree angle, how tall it is. So there's your height. Your length, how long it is. And your width, how wide it is. We need to stop giggling at that. You give all 3 of these measurements, you multiply them all together, and then you divide it by 2. And there's your volume of a triangular prism. Okay? Same thing with the ramp. With a ramp, the height's not going to be indicated in the middle. There's your right angle. This would be the height. This would be the width. And the length would be indicated by how long it is over here. And you have your measurements for a triangular prism. Yes. This right here? Yeah, it's a right angle. Remember, height is always going to be indicated by a right angle. So you want the straight line, how tall this thing is. You don't measure somebody slanted, right? You want them to stand straight up, tall, and you measure, and there's your straight line. So height is a straight line. Straight line will be indicated with a right angle. We have the height in the middle here because this is not a right triangle, correct? But over here, this is a right triangle, isn't it? So the height can be measured right here, right next to it. because it is a straight line. When it comes to triangular prisms, again, please do not forget length times width times height, and then you what? Ladies and gentlemen, divide it by 2. Now, the textbook tells us this, that the base of a triangular prism is the triangular part of the prism. I'm not going to ask this, but just so you guys know, when they ask you for the base of a triangular prism, you're basically just finding the area of one of the triangles. Okay? That's all you're doing. Find the area of one of the triangular faces, and that is the base of the triangular prism. You find the area of a triangle by multiplying base times height, right? In this example, it would be width times height, and then you divide it by 2. So you just find the area of one of the triangles, and there is your base, quote unquote. I'm not going to test and quiz you on it because I don't think it's fair, but just so you know, because next year you're going to work on this. So let's do a group example now. I'm going to go erase all of these. Here is your triangular prism. It's a tent. We will make the height. So for a tent, a good height would be what? Like 8 feet? 8 feet, so you can walk in and out of the tent. The width of the tent, the entrance, should be what? Let's say it should be at least 6 feet, right? 6 feet width. And then the length, I'm going to make this a little bit more fun. We're going to say 14 3/4 feet. And I'm putting a fraction in there on purpose to see if you guys can problem solve. Now, if the problem does not say you need to solve it as a fraction, we do not need to solve it as a fraction. With a calculator, you can easily make a fraction a what?
Decimal.
Do we remember how to make a fraction a decimal? Nobody? So if you want to turn a fraction to a decimal, it's already a division problem that hasn't been solved yet. Remember, that's what we learned this year, right? Fractions are, actually we learned that last year, didn't we? Fractions are division problems that haven't been solved. Yes, you guys did. I remember vividly doing this last year. Remember, a division symbol is literally a fraction that is not written out. The 2 dots represent the numbers that are not there. When I put numbers there, like 3/4, it is now a fraction, which means it's a division problem. 3 divided by 4 is 0.75 in decimal form. So instead of me saying 14 3/4 feet, I can just say 14 point, ladies and gentlemen, 0.75 feet. So again, the volume for the formula for the volume of a triangular prism is length times width times height. Ladies and gentlemen, help me finish it off. Over 2 or divided by 2. With your group, find the volume of this tent, please. So, to find the volume of a triangular prism, again, you multiply length times width times height and then divide by 2. Pixar, I'm going to pick on your group. You guys did this, correct? Yes? Yeah. Okay, so on a calculator, what did you do first? Okay, so you did 14.75, correct? Times 6. And that gave you 88.5. Now, I want to highlight something. What she did right now, because eventually we're going to get to this, is she just multiplied this length and this width. She just found the area of the bottom of the tent, just so you guys know. And this is going to be part of what you guys are going to work on going forward. So she just found how much space is in the bottom of the tent. So the area of the bottom of the tent is 88.5 feet. Ladies and gentlemen.
Yes.
Squared. Again, when we multiplied 2 numbers together, it's the area of the bottom. So the bottom of the tent is 88.5 square feet, okay? Now, normally, like Kevin said, that would technically be the base, because again, the base is whatever is on the bottom. But when it comes to triangular pyramids, the base is one of the triangle faces. So if I were to break this question down more and say, okay, what's the area of the opening of the tent? then you can find what the area of that triangle is. Okay? We'll do that afterward. So we found these two multiplied equals 88.5. Then we multiply it by what, Pixar? By the height, which is what? We're going to multiply it by 8. That gives us 708 feet cubed, but it's a what, ladies and gentlemen? It's what? A triangular prism, which means I have to take this number and divide it by 2. The volume, okay, Mateo, go sit at that table. Right, that seat right there. Ariel, you need to keep them both in check. If they're goofing off, you need to let me know. Jaden, you're going to be the next one moved. Now that we've divided it by 2, the volume equals 354. Help me finish this off. Feet cubed. So that's how much can fit inside of the tent. 354 cubic feet, or feet cubed. Now, if I were to take this another step further and ask, okay, how big is the opening of the tent? Like, how big is the opening of the tent? If that whole triangular face opens up, like unzips and opens up so I can walk in and out of it, you would just find the area of that triangle, right? What two numbers are related to that triangle in order to find the area, ladies and gentlemen? 8 and 6. You would literally just do 8 times 6 and then what?
Divided by 2.
Divide it by 2. 8 times 6 equals 48 divided by 2. So that opening has 24 what? 24 what? What's the measurement, ladies and gentlemen?
Feet.
And what should it end in?
Square.
Squared, because we found the area. We did 2 numbers. So that opening of the tent has 24 square feet, or as Kevin highlighted earlier, according to the textbook, that is the base of the triangular prism. That's how you find the base of it. You just find the area of the triangle. Any questions so far on this? All right, let's get into what the expectations are with the homework. Homework has 9 questions. You are to do all 9, and you are to draw out all of these shapes. When you do that, let me highlight one of these. So look at number 8. I know some of us are going to struggle drawing these out. This is my hint to you guys. Focus on one part of the drawing, and then get the rest of it drawn. Normally, pick one of the bases. So for me, I'm going to pick that top triangle. There's that top triangle, right? Now I'm going to draw the rest of the shape. Here's a rectangle for the side. And now I'm going to do the dotted lines, and I'm going to do my best to make sure that I'm able to replicate. It's not going to be great. It's not pretty. It's not as exact as the other one, but it does its job, right? So please draw these out, then write out the measurements and so on. And for your work, you need to show me, write down what you're plugging into a calculator. So for number 1, what 3 numbers are you plugging into a calculator, ladies and gentlemen?
3, 5, 7.
So you would do 3 times 3 times 7 equals, and you and your group have calculators. Do that now. What does that equal? Some of you can do it mentally. What's 3 times 3? What's 9 times 7? So what's my answer? 63. You guys are all over the place. Together. 63. That was somehow worse. Let's try that again and not yell. 1, 2, 3.
63 centimeters cubed.
So 63 centimeters cubed is the volume, and you're going to want to write volume equals. This would be the example for number 1, the work. You draw that out. You give me the measurements. You put what you put in a calculator. Now with a triangular prism, you would still do all 3 multiplied by each other, but then you tell me what it equals, and that number would be what? What would you do to that number? Triangular prism. You'd multiply all 3 numbers, tell me what it equals, and then that number would be... What do you do in order with a triangular prism? Somebody said it. Then you're going to show me that it's being divided by 2 and then what that equals. This is the expectation for this. 9 questions. That's all. This is due by the end of the period on Monday, along with your mid-chapter check. Your mid-chapter check is, again, page 650. You should be able to do this today since you've already been taught all 4 lessons. Again, if you want to do this all this weekend and then Monday you have a study hall period and you get permission from me to work on another person's class, other classes work, that's fine. But it all needs to be done by the end of that period. Adrian, it needs to stop. Don't do that. Any other questions, comments, concerns? Stop. None? All right.